Okay, students, we're going to go ahead and review polynomials in scientific notation. Uh, Multi-monomials. Mon means one. So monomials refer to polynomials. Mon means one term. Okay. All right. So you need to remember your exponent rules. Okay. When I have a 2 outside, I'm just going to make this bigger so you can see it easier. 2e over 3 squared is what it says. I need to distribute this 2 through everything inside here. So it really now says 2 squared e squared over 3 squared. So what's that equal? What's 2 squared? 4. E squared is e squared and 3 squared is 9. There's my answer. And if there's a negative, that would include the negative is distributed to as well. Here we put together like terms. 2 times 4 is 8. I have 1a here and I have 3 a's there. That means I have a total of 4 a's. I'm adding the exponents. But I multiply like bases when multiplying like bases, add the exponents. Okay, so you gotta know what a base is. So if I have x cubed, x is the base, 3 is the exponent. So when it says 3 cubed times 3, those are like bases because both bases are 3. Remember that means it has, they expect you to know that has an exponent of 1 on it. And so 3 cubed, what does it tell me to do? Add the exponents. So it's 3 to the 4th. And if they ask you to simplify that, 3 to the 4th is 81. 9 times 9 is 81. 3 squared is 9, and that 3 squared is 9. 81. Okay, here I have 2 b's, and here I have 2 b's, so it's b to the 4th. Add the exponents, c squared is c to the 4th. And there's that answer. All right, here I'm just multiplying. And so the 5 will cancel the 15 3 times. So I have a negative, and I have 3 times 3 is 9, and r times r squared is r cubed. Remember, that's a 1 there. 1 plus 2 is 3. That's a common error that students forget, is that it's 1 there, and so they put r squared. We're actually looking for physical numbers. You have to be smart enough to add that on there. Okay, dividing monomials. When we divide monomials, we subtract the exponents of the like bases again. And I just divide the coefficients. 15 divided by negative 3 is negative 5. I have 3. Let's make this a little bigger here. Okay, you can't see that's x cubed. Let me just write it again. 15x cubed y to the 5th over negative 3 x to the 5th y squared. Now let's get rid of that. Okay. So 15 divided by negative 3 is negative 5. I have, you can subtract your exponents, so 3 minus 5 is negative 2. But what I like to simply do is just ask if they're all positive. Oops. If they're all positive, I say, where do I have more x's? In the numerator or the denominator? I have more in the denominator. So the x can be down there. How many more do I have? I have 2 more. So there's my x squared. Where do I have more y's? Numerator, denominator. In the numerator, how many more do I have? Subtract them. 3. And there's my answer. That's how I go about doing it. Okay. Because then I can get right to the answer without having to change negative exponents to positive. So what a lot of books teach you after you have your negative 5, you do 3 minus 5 is negative 2, and then 5 minus 2 is 3 when you subtract down. Well, then after that, you have to remember to switch that negative exponent to a positive, which means you drop it down to the denominator, and then you get this answer right here. They already did the first time. So you can do it either way, but you have to remember to go ahead And because I used to say make the exponents positive on your answer. All right, this one, I'll rewrite it. It says 32 x cubed y squared z to the fifth all over negative 8 x y z squared. Okay, so what does that simplify to? 32 divided by negative 8 is negative 4. Where do I have more x's in the numerator? How many more do I have? 2. Where do I have more y's? Numerator. How many more do I have? 1. Where do I have more z's? Numerator. How many more do I have? 3. And there's my answer. Nothing in the denominator. Okay, next, scientific notation. You know, for scientific notation, it's something times 10 to some power. This has to be from 1 and less than 10. This first number, you have to make it so that this first number is greater than or equal to 1 and less than 10. So no double digits in this first number. So that means I have to stick that right there to make it 9.621. That's between 1 and 10. So 9.621 times 10 to what power? Now I have to ask myself, how many places do I have to move it to get back to its original spot? 1, 2, 3, 4, 5 places to the left. Going left is negative. So if I type that in my calculator, I would get that answer. Here I can't have 41 because that's not between 1 and 10. So 4.1. That first number has to be between from 1 to 10. So 4.1. And remember, that really means it's like I'm going to put 0.0 if I wanted to at the end. The decimal place is at the end. So how many places am I having to move it? 1, 2, 3, 4, 5, 6, 7. So it's going to be 10 to 7. So I'm going to go right. It's positive. Okay. You might say, oh, this looks like it's in scientific notation. No, it's not, because this first number has to be between 1 and 10. 1 includes 1. So it's 7.6. How many do I have to move it back? 1, 2. So I'm really going back 2 more. So negative 3 minus 2 is negative 5. And there's that answer. Division. I can divide these by themselves and then divide these because these are like bases. What's 3 divided by 1.2? That's going to be 2.5. You don't know, put in a calculator. Times 10 to the what? When I subtract, I have division, so I subtract my exponents. Negative 2 minus 3 is negative 5. And there's my answer. Why can I be satisfied with that answer? Because this first number is between or from 1 and less than 10. If it wasn't, I'd have to move the decimal to make it that way. And that's an example of this one right here. So, for example, multiplying 9.72 times 4.8. 9.72 times 4.8. 9.72 times 4.8. Notice it gives me 46.656. 46.656. Let's just verify I wrote that down right. Yes, 46.656 times 10 to the what? I'm adding, like, since I'm multiplying, I'm adding the exponents. 10 or 7 minus 10 is negative 3. You might think, oh, that's a scientific notation. No, it's not. Why is it not? Because its first number is not between 1 and 10. 1 inclusive. So I have to put it here. So it's 4.6656 times 10. Well, how do I move it back? I'm going 1 to the right, so I'm adding 1 to this. Negative 3 plus 1 is negative 2. There's the answer right there. Okay. Find the degree of each polynomial. Degree means highest sum of exponents on the variables in any one term. Okay. So first off, I want to talk about one term at a time. You find the degree of each individual term, and it's whatever has the highest exponents of all the individual terms. And I add the exponents together only on the variables. So this degree is 4, 2 plus 2. This degree is 3, 2 plus 1. This degree is 5, 3 plus 2. And so which one's the highest? 5 is. So this is degree 5. Okay. Remember, terms are separated by plus or minus signs. So we have 3 terms there. Next, arrange the terms of each polynomial so that the powers of x, they're focused on the x, are in ascending order. You have to know ascending means to go up. So the smallest amount is 1. There's 1, 2, 3, and 4. So I have negative 2x plus x squared minus x cubed plus x to the 4th. Okay, if you want to put the 1 there, you can. 1, 2, 3, 4, ascending order. Now, standard form, we put it in descending order. So standard form would be the exact opposite, if you want to think of it that way. Standard form of any polynomial, you go highest degree down. So if they ever tell you to put in a standard form, you know to put a highest degree down. And so that would be standard form for that one. Okay, let's go to the next. Adding, subtracting polynomials. Adding, as it says right here, notice what they've done for us vertically. They've put it in order. In other words, they've lined up like terms. And now we just add straight down. So it says 6 minus 1 is 5, plus 5 is 10, put plus 10. 6 minus 3 is plus 3z. And here I have a negative 11. 6 minus 11 is negative 5y. And here I have 6 plus 1 is 7x. Okay, make sure you put the sign with a plus or minus. Now, subtraction means to take the opposite sign of each. I have to distribute the negative 1. It's like distributing negative 1 through there. So negative 9 plus 1 is negative 8. I have minus 3cd. And 5 minus 2 is 3c squared d squared. Notice I'm only adding or subtracting the coefficients. The variables and their exponents stay the same. And that's why they're lined up. These are like terms. The c squared d squared is the same. It's all about the variables have to be the same and the same exponents. That's why it wasn't lined up with this. These don't have exponents of 2 on them. So that's a different term. Excuse me. Okay. Oftentimes, most of the time, it's written like this one. So I have to remember to distribute this negative 1, which means to switch all the signs, which is what we just did up here. But it's usually written horizontally like this. So it really says 7x squared, and I have to find the like terms. Minus 3x squared. I'm just going to put those together, and then I have a plus x, and the minus 4x is plus 4x. And then I have plus 1, and then minus 3 is plus 3. So I just went ahead and put those together, and now I'm going to combine like terms. 4x squared, 1x plus 4x is 5x, and 1 plus 3 is 4. And there's my answer. Okay, next, multi-polynomials. You should see I have it done two ways. One, when it's written horizontally, a lot of people like to, you can do it vertically every time if you want, like we have on the right over here. But this is double distributive property. So x times x, x squared. X times 2, 2x. Negative 10 times x, negative 10x. And negative 10 times negative 2 is negative 20. Then I have to combine like terms. X squared minus 8x, 2 minus 10 is negative 8x, and minus 20. There's my answer. Vertically, notice how they've written, when they've written it vertically, they put each one in standard form, meaning highest degree down. That will help to line up your like variables when you're multiplying here. So 3 times negative 9 is negative 27. All I do is multiply like I did in elementary school. 3 times 2a is positive 6a. We just aren't doing any carrying like you do in elementary school. And 3 times a squared is 3a squared. Now I have a times negative 9 is negative 9a. I line it up under like terms. A times 2a is 2a squared. That's a plus. And a times a squared is a cubed. Now notice they're all lined up under like terms, and now I just add straight down. A cubed plus 5a squared. 6 minus 9 is negative 3a minus 27. And there's my answer. Okay, next, special products. When I square a binomial, I'll write this bigger, 11a to the fourth minus p cubed squared. I'll just go ahead and get rid of that. When I square a binomial, how do I know it's squaring a binomial? Because it has a 2 there. That's squared. Okay, that means multiply it by itself. So some people need to write this out, and they might put it again underneath it and do what we just did on the last page and multiply those together and do it that way, or double distributive property. Well, there's a special rule. That's why it's called special products, that you can just get the answer off the top of your head if you memorize the rule. So rule is, if I have x minus y quantity squared, for example, doesn't matter what term it is here, you're just doing the same steps. You square the first term, so multiply it by itself. You can multiply the two terms together, so x times negative y is negative xy, and then double that, so it's negative 2xy for the middle term. And last term, you just square the last term. Negative y times negative y is positive y squared. That's what will always happen anytime you square a binomial. So 11a to the fourth times 11a to the fourth is 121a to the eighth. I multiply these together and get negative 11 a to the fourth p cubed. I double negative 11 and makes it negative 22 a to the fourth p cubed. Okay, and then I square the last one. Negative p cubed times negative p cubed is positive p to the sixth. And there's my answer. The second type of special products that we have in Algebra 1 is called difference of squares. This looks like a difference of squares if I was factoring a difference of squares. Okay, so this would be what would factor into from a difference of squares. So if the original problem was 9d squared minus 64x squared, that would factor into this right here. Okay. Now, what happens with the difference of squares? Unlike most binomials, every binomial that you multiply by itself or another binomial will always end up in a trinomial, 3 terms, except for this one. This ends up into a binomial when I multiply these together. But when they're both exactly the same, 3d and an 8x, 3d and 8x, and one's a plus and one's a minus, it wipes out the middle term. I'm not going to sit there and multiply that out to show that. Okay, you've done that, and that'd be in a video, perhaps we're talking about it in class. I'm just going right to the answer. So when it's set up as a difference of squares, like that you want to see, you want to just multiply the first two together, and you get your 9d squared. And you multiply the last two together, negative 64x squared, and there's my answer. Notice a binomial, not a trinomial. Every other time you multiply two binomials together, you will get a trinomial. So that's the normal answer, it's a trinomial. Okay, but when it's the same two binomials multiplied together, the only difference is one's a plus and one's a minus. It wipes out the middle sign, the middle term I meant. Okay, that is it for this chapter then. 21 minutes.